insert lat, or you can write this, or you can write LE, which we were writing earlier. So it's the same thing actually, so don't really care about this. Minus 50 kilojoule per mole, again just random values. When we calculate delta H naught sol, it is delta H naught hide minus delta H naught lat, or LE. So this becomes minus 100 minus 50, which is minus 50 kilojoule per mole, equal to minus 50 kilojoule per mole, because minus 100 plus 50, so minus 100 minus 50 kilojoule per mole. So this is the enthalpy change of solution. But now let's take CaOH whole twice, which is calcium hydroxide. Again, so in this case both will be less exothermic, but the change in lattice enthalpy will be more than the change in hydration enthalpy. So let's take the change in hydration enthalpy as 25 kilojoule per mole, and as it is becoming less exothermic, this becomes minus 75 kilojoule per mole, because minus 100 plus 25 is minus 75 kilojoule per mole. And let's take the change in lattice energy as, let's take the change in lattice energy as 25 kilojoule per mole. So so not 25, 50, sorry, this we have to take 50 because it will be much greater. The change in the lattice energy will be much greater than the change in the enthalpy of hydration. So let's take the change in lattice energy as 50 kilojoule per mole. So as it is changing by 50, it becomes 0, because 0 kilojoule per mole. I'm just, this is not possible, but let's take this for reference. Minus 0 kilojoule per mole. So what happens is that, and it's becoming, and this is also because it is becoming less exothermic. So when we calculate delta H naught sol, it will be delta H naught hide minus lat. So it will be equal to minus 75 minus 0, which is the same as minus 75 kilojoule per mole. So we can see that the enthalpy of solution has become more exothermic. So the solubility has increased, because as I said, the more exothermic the enthalpy of solution, the higher the solubility. So from MgOH whole twice to CaOH whole twice, the enthalpy of solution has become more exothermic, which proves that the hydroxides become more soluble as we go down the group. So again, this question comes for 3 to 4 marks as well. So you will write this exact, all these points in one single paragraph, and you will get the 3 or 4 marks. And you have to know the difference between the solubility of sulfates and carbonates and the solubility of hydroxides. So the sulfates and carbonates become less soluble down the group, the hydroxides become more soluble down the group. And that is it for the lattice energy chapter. We have covered lattice energy, the calculations involving lattice energy, born-habercycles, enthalpy of solution, hydration, and we have also covered ion polarization, which tells us about the thermal stability of compounds. So now you're good to go with this chapter. It is very easy. You can practice questions at gceguide.org. I have given the link in the description, and you can email me your doubts at alevelchemistryfree@gmail.com, and the email ID is also given in the description. So keep practicing, and I'll see you in the next playlist.